Howdy, welcome back to ELE 120 PC board design. In previous lectures and exercises, we've built a schematic of a power supply board that will take in 12 volts and will give us out plus and minus 9 volts using one of these kind of DC inverter chips. Inverter probably isn't the right name. It's a polarity reverser. It charges up capacitors and does things to take your positive voltage and give you a sort of mirror image negative voltage. We put the positive and the negative voltages through 3-pin linear adjustable regulators, and we get a regulated plus 9 and regulated minus 9 and a ground. So anyway, we've done this schematic, and we've annotated it. And annotating means allowing it to number all the reference designators like R5 and R6 and C1. And here's a jack over here, J3, and this is U1, U3, U2, some resistors here. They all have reference designators now. Thanks to the annotation process, we also assigned footprints to all these in the process up here. There's a tool that we click on. There it is, that one right there that has a schematic and a footprint in the schematic symbol and a footprint in the same icon. Assign PCB footprints. So we did that, and we ran our electrical rules check, some people call it design rule check. This is an electrical rules check, so maybe it's an ERC or electrical design rule check, and EDRC, something like that. You'll hear people often talk about DRC or ERC, often meaning either the same thing or two very similar things. We then did the generate netlist function, and we created a netlist, which is a text file containing all the I believe it's a text file. For many tools it is a text file containing all the information about what pins on what chips and are connected to what components and all that sort of thing. Again, none of the printed circuit board layout has been done, but we have captured the schematic and checked it for correctness. We have all sorts of things here. Power flags, important to know why they're there, and if people have questions about power flags, email me. I'll do a special little ditty on it. We have our wiring and everything, so we're really ready to consider printed circuit board layout. So if we go back to our kind of main administrative panel here, and we click on the PCB layout editor, which is called PCB New, if you care about the name of the program. But we click on that, and up comes something. You can see some dark background and some red lines down here, which is a template for a drawing. And if we were to go up to here to view, zoom to selection, and then put a box around that area down there, we'd see our page settings are already filled in. I think, page settings here. And if you wanted to change them, you could. I notice we don't actually have actual revision number in there. So if you want to, we can add something like A1 here, and we can let's see. Yeah, you can see it down here, revision A1 now. So anyway, that's the that's all the kind of documentary information. And we can view, zoom to fit to get the big thing. Now, we'd like to pull in that net list and get some parts so we can start to move them around and make a board. And one of the ways that we can do that, the maximum size board for the PCB fabricator that I usually use, called JLC PCB, is 100 millimeters by 100 millimeters. So one of the first things I might do here is go to edge cuts. Over here we have all the different layers that you can be on here, and normally we kind of point to front side copper. But I go to edge cuts here, and I'm going to add a graphic polygon and go in here, and let's see, we'll have to see how long we make these lines here, but we can resize it as well. So there's, I'm going to right click that, and yeah, try it again. So I draw it like this. And there we go. I double clicked it to end it, and I got these yellow lines. Now these are edge cuts. This is where the PC board manufacturer is going to cut the board. They'll make multiple copies on what's called a panel, and they'll cut this out. So let's do a view zoom to selection here. See how big this thing is. We can use a measuring tool down here, and we can click once, and we get this ruler we can use anywhere we want. So if I put this over here, I'm at 64.7. So that's, I'm going to redraw this and make it bigger. Okay, so I'll cancel out my measuring thing. I'm going to go up here and make sure I'm in the selection mode with this arrow, and I'm going to grab this guy, and let's pull him out here a little farther. Another thing we can do is we can add a dimension. You see this N with the arrows between it? We can add a dimension here, and we can make it a little easier on ourselves. I'm going to try it again. Whoop. Let's see if we can get out of that tool, and it says 100.33. I think I'm going to want to, well, I may leave it like that for now, because we're actually going to make our board less than that. So I'll put another dimension up here. I'm going to zoom out a little bit. I'll put another dimension here and try to make it as close to 100 as I can. And it also says 100.33. And I ended that with a double click. And now I can go back to my selection, and I can grab some of these things here somehow. Click this one. Yeah, this one I can grab. And I can move it over here for now. Like I said, we're not going to have, our board isn't going to be anywhere near as big as this. So we can, although I would like to be able to select these things, you can always try to select them like that. I was able to select them and get rid of them. So I can use add graphic polygon, or I can use add graphic lines. So let's try this. We'll do something up here that looks like it's about the right distance. Okay, I didn't get that quite right. Let's see if I can move it or something. Maybe make the other one longer. If I move each end. And then I can hopefully select this guy, yeah, and pull him down, stretch him down. So now I have something that looks like it might be 100 by 100. You can fit a lot on that size board, and you can get 10 of those boards made for $5. And if you want the shipping, so you get it in about a week to 10 days, it's maybe another $17. So for 20 to 22 bucks, you can have 10 boards made. That would be two-sided, silk screen on both sides and solder mask on both sides. And of course, any vias going through the board would be plated through, which would meet all our requirements. So let's start out with this as our board. And oh wait, I'm not really where I want to be up top here, am I? So we'll continue the process and move this up here. Now we have a board that we can be proud of. We might go over here and save it. I don't know. So the next thing we want to do is we want to bring in all our parts, all the footprints for all our parts with their connections, and bring them in so that we can, and I'm going up here on the net icon with the kind of wires on it. In the schematic page, this said generate netlist. On the PCB design page, this says load netlist. So if I click on this, I come up here and it says, names my project, and it says that.net. And so I'm going to update. So everything's good here. Keep existing symbol to footprint association, certainly. And we will update the PCB. These changes cannot be undone. Are you sure you want to update the PCB? I'm going to go yes. And yeah, so we're going to do that and close. And here are all our parts brought in from from our footprints. And these resistors look pretty large, but for our first PCB, I like using these big parts. We'll stick with this, and we'll figure all this stuff out. So the question is, how do we best lay this thing out? That's what I wanted to talk about in this video. And I do not fancy myself a great layout person. I fancy myself one who knows some of the things that are good and bad, and knows a few hints along the way. So we can try to do that. But what we have here is called a rat's nest. You see all these wires, all our connections are shown, and they're sort of like connected by rubber bands, if you will. If I select a part here, or I guess I selected a couple parts and drag it out, you see how the connections move. And the ones that are jumping around are like ground or plus 5 volt, some of the power connections, because there's many ways they can be connected, but most of our nets stay right where they are. So I think what we'll do is we're set to zoom to selection, aren't we? Yes, we are. So I'm going to go in here. I guess maybe go in here about like this. Now we didn't zoom in, did we? View, zoom to selection. Okay. So there's my selection. Maybe I'll click on it again. Zoom to selection. Okay. Yeah. I guess something about being outside the edge cuts or something. So we don't want to be on the edge cuts layer anymore. Let's get off of that. Let's just point to front side copper for now. It's not that important for us. I'm going to zoom out a little so I can see the board edges. And what we're going to do here, see, I might as well make this full screen. Sorry about that. We want to play around with this, and the thing that we obviously want to do is explore the locality of parts to see what parts are naturally next to each other and make the simplest connections possible. You know, some of these resistors, I see R2 and R3 are connected here. They probably want to be together. Whoop, did not mean to do that. We will zoom back out. And there we go. And I think you can also zoom sometimes with your mouse pad. And unlike the well, I think the schematic does have this, so we can use these sliders to put us where we want to be. So I'm going to make this a selection thing. And we can now select individual parts. Let me see if I can do this correctly. There, it's highlighted now, and we can click and drag it around and put it where we think it would be best. And if we do the R for rotate, you know, it might be that this thing does better if it's connected. You probably want it near the edge. Well, but the plug sticks in this side, so maybe we're going to need to rotate this a couple of times and stick it in there somehow, or maybe it's going to have to go over here. I don't know. But that's what you got to do. You got to grab this stuff and play around with it. Start moving it around. Spread it out a little bit first. And then you'll begin to see what can be done. And it just takes some creativity here, you know, and a lot of common sense. And you'll also learn sometimes you can get funny and you can actually select part of the footprint, and you just don't want to do that if you can avoid it, and shouldn't have to deal with much of that. But we know that, let's see, we just have to spread this stuff out and kind of see who connects to what. That'll help us to see the rat's nest better. And so sometimes it just takes some spreading around. Now, here's one right here. Well, no, there are other connections. I was going to say, here's one right here that could probably benefit from a flip. I think it could. So I'm going to rotate it twice, and I'm going to move it out here, and I don't know, that looks better to me. I don't have as many wires crossing. This guy here, I don't know if he works better rotated. Maybe he does, maybe he doesn't. It's up to you. Maybe you want to keep him so he's got the same orientation as this one. You know, there are other preferences here. Some companies like their integrated circuits all lined up with pin 1, or they like their capacitors all a certain way. For me, I don't care that much for my own boards. I just want to make it so things draw well. So I see something going on here where R1 and R2 are kind of related to each other and give them a little room, and they connect to ground, and R3 and R3 and this guy are connected together. I gotta believe R4 is related in here somehow. So yeah, it looks like R3 and R4 would love to be laid out. Something like that. Now, as I look at this thing, R5 will move him down here. It might be that these guys right here, this guy, it might be that these guys want to be rotated around a little bit. maybe here, and this guy over here. Again, I'm just looking at this thing. That might work nicely, and then this guy here comes down to here. And we don't want to push things right up to the edge. There are some design rules about, you know, how close to the edge you can come. And we'll be doing another design rule check essentially to see how that all goes. I'm going to leave this thing here for now. We've obviously got to figure out some other stuff here. Looks like R5 and R6 are related here, and this is where having a copy of the schematic can be handy too. I think we can see that if we want. We go up to the let's see. Well, I'm not going to do it right now, but we can. If you have the schematic, you have the rat's nest, but the schematic can help you remember what resistors are for what purpose and that sort of thing. And you can move things around. And now this particular part here is a TO220, which you can look up, but this back is something that would like to be mounted to a heat sink in case you pulled enough. I don't think you'll pull enough power, you'll need it, but if you even want a small heat sink, you might want to leave a little distance on this back side of this transistor so you can put one in. Transistor, it's an integrated circuit, but it's in the form of a power transistor. And some of this stuff, maybe would like to be, near the edge of the board and that kind of thing. Not sure, again, we're not sure what all these different J numbers are for. But some of them are actually where we bring our +9 and -9 off. So here's, here's where our other part goes. This guy, if I remember correctly, this guy wants to be somewhat near the power jack. Let's see if bringing R6 over here. It doesn't look like it really wants to be over there. R6 might want to be something like that. I don't know. And R5, let's see where R5, what it wants to connect to. It really wants to connect to this capacitor down here. So, well, let's see. Is there any advantage in bringing any of this stuff? This guy looks like, this guy looks like he wants to be up near this chip. I think I remember that from the schematic. And this guy here wants to be up near this chip. This guy looks like he wants to rotate it like that and I think he would be happier like that. This guy here, yeah, he looks like he'd be happy right up in this area. He's got a connection over to this guy, which shouldn't be too hard to put in place. And maybe I put him along the bottom like this kind of thing. So, this guy looks like he'd really prefer to be up in this area somewhere. That may not be what you really want from an operational standpoint. I don't know. I'm just pulling these things around to try to get a better looking layout. And this guy here, he might want to flip around. See, we got a crossover right there. And looks like you might be happier that way. So now our connector here, I wonder if he were to rotate, if he'd be any, well, he can't be pointing inwards, sorry. He's got to be pointing outwards. And that might be okay. I don't know. Now, if you guys see this in a better way than I do, don't be surprised, because I am not particularly good at this. As I've told you, I've met people who they just get it immediately, and they've done it a lot more than I have too. So I don't pretend to be any better at this. Now, we do have some crossovers. We got some nodes that go all the way around here. You know, we might want to. You just have to explore. It's really It's really an exploration here of what can possibly work. All right, and this guy here might really, yeah, he might be better off down in this area somewhere. And he might be better off if we rotated him. Let's see which way he likes to go. There's once, there's twice. This one, to me, I see. I don't know. I don't know if I see more or less crossovers with that. And that's got quite a few crossovers. That's got a lot of crossovers in this area, at least on that side. Although sometimes, you know, I mean, we do have 2 layers to work with, so crossovers are not the worst thing in the world. And, you know, we can maybe pack some of this stuff in a little better. This guy, now I look at him, looks like he would like to be flipped around a little bit, maybe moved in here. And what would happen if we took this guy and rotated him once like that? Maybe we bring him in there. Oops, all right. Bring him in here like that. And now we're able to bring this guy into here, and we can shrink this thing. And now, again, you guys may see this in a much better way than I do. At this point in time, what you could do is select all this stuff and push it up closer to the corner. All right, and we could do something like we can take this guy and we could bring him over here like this. Whoop, yeah, I'm going to zoom out a little bit. I could take this guy and bring him here like this. I think those barrel connectors, well, they don't have to stick over. Some people make them stick over, some don't. So how's that? And then we can grab like, okay, we got the right kind of selection on here. Maybe we can grab this guy here. We're in why don't I go on to the edge cuts layer where we do this work, and I will grab this thing. Nope. This is great teaching demonstration here. Okay, it looks like I've got parts of it. I think sometimes what might be easier to do is just get rid of that stuff. And we're on edge cuts, and we'll just redo this. come down here like so. And this guy here, I guess we just have to see if we can even select him. I don't know what the problem is here. Oh. I will get it, trust me. And I'm right clicking and doing cancel. So now I'm down to there. I'm going to, rather than change these dimensions, I'm just going to get rid of them. At least I think I'm going to get rid of them. Maybe if I'm going to go back on front side copper and click on that thing and nope. I'm going to maybe that thing is on edge cuts, I'm not sure. Go back to edge cuts. Select it. There we go. Now we've got it. Well, maybe we can shrink it. What do you think? Oh, no sirree, Bob. There's no shrinking it. I think what we'll just do is get rid of it. Don't know, I'm obviously not doing well on the selection, but so let's add dimensions. Let's do a zoom to selection. And let's see. Hey, that actually worked. You just have to play around with whether you click something first or second or whatever. Actually going to move this guy and give myself a little more room. I don't know, it doesn't, for this rat's nesting, it doesn't seem to matter whether I'm on edge cuts or front side copper, but again, your mileage may vary, but I think you can figure it out. And so let's put our dimensions on here. I'm going to just move over here like this. And I'm going to come down here and just going to go boom. Oh. Nope. No. I'm going to do a Control Z, I guess, for and try this again. So we're about 35 millimeters in this direction. And then come back over here and we'll put one down here to indicate that we are 81 in this direction. And again, I think I used really big resistor footprints here. Our resistors will be tiny, it'll look stupid probably, but I'm just trying to get our first board kind of through the process and see how we do with it. If you look at this guy here, no, got to get out of that tool and go back to selection. I'm seeing a crossover right here, and I'm thinking, gee, can I get rid of it? Well, maybe I can. Maybe I can swing things like this around. Whoop, nope. Swing things like this around, maybe. Not sure. They're both 1 microfarad. But if I put this one over here and I put this one up here a little bit. I think I got rid of it. And I still got the bottom crossover. So then I can take, and it doesn't look like I can get rid of this crossover because no matter where I move it, this J2 is connected. But the only way to get rid of that is to move J5 and J2 on the inside of the board, which is probably not really what you want. So you do what you think you want. I think these stake pins, you probably want to keep them toward the outside of the board. So we'll just take advantage of the double-sided board at that point, and have those available to us. Okay. And I have J1, J2, J4, J5, and this is J3. So I think we're all set there. J2 and J5, I wonder if they are. This could be minus or something. We'll look at them in the schematic. See, if I select on something where there's two things, I see reference C1, reference C5. I can move reference C1 over so it's not on top of reference C5. And I can move reference C5, just makes it a little easier during assembly to know which parts are which. Here's a C4 up here. Pull that down here. The stuff that's in blue is actually going to go on the silk screen. The stuff that's in white just tells you values. So we may want to grab R2 here and just bring it down. The resistor may partly cover it, but we certainly can't have it overlapping the edge of the board. Here's J6. That's probably okay. And R5 and R9 look okay. J3. So, this stuff looks like it's going to work. So let's go ahead and I'm just going to zoom out here a little bit, and I'm going to save this file. Or the other thing we can do is this. I think I'll just save this file. So I'll go up here to File and Save. And what I'd like you all to do, I'll post this as a homework, is get to this point, or not necessarily this point, but a point where you've done the best you can to eliminate crossovers and that thing, and get something that looks like it could be routed with double-sided routing. That is, keep the number of crossovers low, and you'll be able to route it. And what'll happen is I'm going to try to get the parts for this thing, and we'll do a little joint. We'll do schematic reviews of everybody's schematics and design reviews of the PCB layout. Make sure we've passed all the tests, and I'll either order mine, or anybody who wants to order theirs can spend the $20. We'll see if we can get some of these parts and build this thing. Or if you want, and you rather have you look at the resistors and see their actual physical size in the data sheet, you could go and replace your footprints for these resistors and pack this thing in a little smaller even. But okie doke. So that's it for today, and please try to get your project 0001 up to this point, and I'll post a screenshot of this layout. And I have another layout I did that's I don't know if it's probably worse than this, but I'll post it anyway, just to give you ideas of how many crisscrosses I wound up with. All right. So thanks for watching, and I'll post this stuff right after this. Okay. See you next time, and take it easy.